Right, the rule to express as a sum of logarithms. Right, one log as two separate logarithms. Well, here's the rule. Log to base b of m times n is log to base b of the m plus log to base b of the n. It's a bit like remembering with exponents. Remember kind of how logs, we can think of the inverse of exponentials. Well, remember when you multiply, look at this, when you multiply, you end up adding the exponents, don't you remember that? Okay. So, as two separate logs, the multiplication becomes a division, and you can prove it by, so well, let's just actually do the answer to this one here. This is going to be log to base 2 of x plus log to base 2 of y, okay? And we can actually show that working if I do it with things we actually know. How about this? How about log to base 10 of, let's say, 100 times 1,000. Oh, sorry, I put that comma in the wrong place, but anyway, 100 times 1,000. Okay, so what we're saying is that if those are two things being multiplied by each other, okay, so 100 times 1,000, then I should be able to do this. Log to base 10 of 100 plus log to base 10 of 1,000. Okay? Well, let's have a look. If I actually do multiply these, 100 times 1,000 is 1, 2, 3, 4, 5 is 100,000. Okay? So if I just get rid of that, log to base 10 of 100,000 is 5, because 10 to the power 5 is 100,000. Put it in your calculator if you need to. Just do log to base 10, the log button of 100,000. It's going to give you 5, okay? If I do them as two separate ones, log to base 10 of 100 is 2. Log to base 10 of 1,000 is 3. If you add those two together, you get 5, okay? So that's just proving the rule there with numbers you know, or you can see it in your calculator. So the rest of these, any of these, it kind of doesn't make any difference really. Okay, if we look at this one, this is log to base x of 4 plus log to base x of y plus log to base x of z. It's just because it's got three things, okay? So three separate logs, but pluses. So, have a guess what the division is. It's going to be a subtraction. Here's the rule, okay? Log to base b of m over n is log to base b of the m minus log to base b of the n. Okay, so there's the general rule. Copy if you need to. Okay, so, and again, you know, so this is just log of x. Oh, it's ln. Sorry, it's ln. That's why there's no base. Remember, that's base e. So ln of x minus ln of 11. And there you go. I mean, so if you proved it with numbers, if I had the log, I'll do log to base 10 again. Log of 1,000 over 100. Well, if I do it straight as it is, 1,000 over 100 is 10, okay? And log to base 10 of 10 is 1, okay? So the answer to this will give me 1. But if I decide I want to separate it into two separate logs, it's log of 1,000 minus log of 100, okay? Well, remember, log of 1,000 is 3, log of 100 is 2, and again, 3 take away 2 is 1, which is what we last time, okay? So, final slide. Okay, the product rule. Now, this is probably the easiest one of the lot, and it's this. Log to base b of m to the n, you just bring that to the front. So that is n log base b of m, okay? So that's fairly straightforward. Can you see if I just bring that 4 to the front, that's going to be 4 log to base a of t. Now again, we can show that working with nice numbers. If I do this, log to base 10. Oh, here's a good one. Here's going to be a good one. Of 10 to the 2. Okay? Now, there's a separate rule for this. But if we think about this, this is 100, isn't it? Okay? Log to base 10 of 10 squared is log to base 10 of 100. Log to base 10 of 100 is 2. Okay? There you go. And that's it. But if I did this, bring the 2 to the front, what we're saying here is 2 log to base 10 of 10. Remember, it's just this part now, because I've kind of just put the 2 to the front. Well, remember, log to base 10 of 10 is 1. 2 times 1 is 2. Okay, so again, just showing you how that works. Right, so that is the 3 rules. Of course, we're going to put them all together and do some more complicated ones. That's it for now.